Okay, let's take a look at solving literal equations. Literal equations, as they're commonly called, are ones where there are not, um, you're not going to get a discrete number. You're not going to, when you solve, you get like x equals 4. They're often used in formulas. They're often used in equations that have multiple variables. So that being said, it has to indicate which variable you will be solving for. We're pretty much going to follow the same steps still, taking a lot of notice around doing inverse operations on both sides of the equation to isolate a variable. So here, if you notice, it says solve for m. So we need to get rid of the negative h. In this next problem, it says solve for w. So we need to get rid of the 5g. And get rid of is kind of a misnomer. You're not really getting rid of it per se, but it's kind of just a layman's terms for what we're trying to accomplish. Here it says solve for x, so we'll be trying to, in getting x by itself, get rid of the b and get rid of the h. Similarly here, as we solve for p to isolate p, we will be getting rid of the a and um, the minus d here. So let's just take a look at how to do that. Some of the major questions you want to keep in mind are, um, what do we want to get rid of? By what operation is it attached to the variable we're solving for? And what undoes that operation? Those are three very essential questions. So here, if I'm solving for m, I want to undo the negative h, which is attached to the m by multiply. So I will just do a simple one step of division on both sides by negative h. So negative h over itself is 1, making this m. The only thing to simplify here is negative over negative, k over h. You also want to note that h cannot be equal to 0 because you cannot divide by 0. Okay, so now in this next equation, where we'll be solving for w, we take a look and we ask ourselves a question, what do we want to get rid of? Well, that's the 5g. How's it attached? Well, it's attached by addition. What undoes addition? Subtraction. So to somewhat annihilate the 5g, we will subtract 5g from both sides. So negative g minus 5g is negative 6g, which is equal to w when we just, again, good writing is about bringing things down that we don't do any computation on. And 5g minus 5g cancels. So we get that it is w equals negative 6g. Now, number 1 and 2, they're both one-step equations. In 3 and 4, we're going to see we have two-step equations. So again, when we're doing two-step equations, you want to undo, add and subtract, then undo, multiply and divide, because again, this is the reverse of PEMDAS. Because solve is to undo PEMDAS. It's to go backwards. Simplify is go forward. So it's almost as if you can see the PEMDAS in this direction when I turn the little organizer upside down. But again, we need to think of it as going backwards on PEMDAS. So you're actually going to do add subtract first. You're not really doing it, you're undoing it. So let's take a look. So here, if we want to get x by itself, we need to undo the plus h. The inverse of plus h is minus h. So now we've got c minus h, which is in fact c minus h. They're not like terms, they cannot be combined. Okay, and then h minus h will cancel. And now we need to undo the division by b. So to do that, we'll multiply by b, because that is its inverse operation. And then we will do it on both sides, as often referred to as the golden rule of mathematics or algebra. Whatever you do on one side of the equation, you must do to the other. So this answer is now x equals b times the quantity c minus h. Okay, you don't necessarily have to distribute that. Leaving your answer that way is fine. Moving right along here to example 4, where we're going to get the p by itself. We're going to solve for p. So to do that, we're going to undo, add, and subtract first. So we're going to take that minus d and add d to both sides because that is the inverse operation. So we're going to bring down the AP. Negative d plus d is 0 equals f plus d. Again, they are not like terms, so you are in fact not able to simplify them. One last step to get p alone, we're going to undo the multiplication by a by doing division by a. So right here we have that our final answer is p equals f plus d, the quantity thereof, over a. And again, probably good to note that a can't be equal to 0 because there's no such thing as division by 0 anywhere in mathematics. So, just for the record, we are trying to, in these simple literal equations, a couple one-step equations, a couple two-step equations, trying to follow that basic principle that we would even if these had discrete numbers in them. You would be undoing additions and subtractions with the inverse operation, then undoing multiplication and divisions with the inverse operations. In more complex problems, you would find yourself trying to potentially distribute, collect like terms, and get all the variables you're solving for on one side of the equation. And if we take a look at some harder examples later, you'll see that.